All right. So this is section 4.5. On this problem, we want to find the horizontal asymptotes. If the powers are, if you remember from algebra, if the powers are the same, the horizontal asymptotes always start with y equals, by the way. The horizontal asymptotes are the coefficients. So the horizontal asymptote is 3 over 2. If the powers are the same. If the powers in front, the highest powers, if the highest power on the bottom is higher, then the horizontal asymptote is always 0. Power bottom higher, then the horizontal asymptote is always y equals 0. And if the power on top is higher, did anybody find out what the horizontal asymptote?
There's no horizontal asymptote.
Exactly. No horizontal asymptote. Because if you remember in algebra, you then had, that's the top. That's the top. And then you had to find the slant asymptote. Remember, if the power on top was higher, it didn't have a horizontal asymptote. It had a slant asymptote. So, and then you had to find that slant asymptote by doing long division. All right, so now that we know that, or we just refreshed that from algebra, let's do some limits. And these limits, I think, are really easy. You just have to look at the numbers. I mean, I'm really shocked at how some people don't get these. So we're just going to find infinite limits. See, these are infinite limits. And once again, limits to infinity we can find when they say limits to infinity. If x approaches infinity, if we put infinity here, this is 5 minus 2 divided by infinity. So somebody tell me what 2 divided by infinity equals. Just 2 divided by infinity. Okay, try this on your calculator. 2 divided by 10. I get 0.2. I'm just going to do 2 divided by 10. If my pen lets me write it. I get 0.2. Do 2 divided by 100. I get 0.02. 2 divided by 1,000. I get 0.002. 2 divided by 1,000,000. I get 0.0000002. Where is this going? 2 divided by infinity equals 0. Do you see? It starts, the closer you get to infinity, the more these answers approach 0. They're getting closer and closer. Really small, small, small. It approaches 0. So 2 divided by infinity is 0. 5 minus 0 is 5. So this limit equals 5. Because 2, do you see the power on the bottom? The power on the bottom is larger, so there's no, I hate to look at that. I say look at it, 2 divided by infinity is, this is kind of, even this, when the limit approaches, x approaches infinity, that equals 0. What does x over 2 as x approaches infinity? What does x over 2 equal? Infinity divided by 2 is still infinity. Do you see the difference? 2 divided by infinity equals 0, but infinity divided by 2 still equals infinity. I just want to make sure we understand that. In this problem, I'm going to rewrite this 3e. Oh, by the way, you don't even need to do that. I'm going to leave it like it is. I know the book shows this a little bit different. This is 3 over E is 2.71. Let's just put 2.7 to the infinity power. If you look at 2.7 raised to the 10th power, I get 20,000 something. 2.7 raised to the 10,000 power is even larger. Do you see? So this 2.7, any number raised to infinity, any number, greater than 1, by the way, not a fraction smaller than 1, but any number greater than 1 raised to the infinity power, greater than 1, it has to be greater than 1, gets larger and larger. So this is really 3 over infinity, and 3 over infinity is 0. We already talked about that. 2 over infinity is 0. 3 over infinity is 0. So the limit of this equals 0. And finally, if you look here, I'm going to do the actual math on this. The limit of this, when the powers are the same, the limit actually equals 2. The limit on this actually equals 2, but I'm going to show you the mathematics behind that. The algebra, it's just algebra. So if I have 2x minus 1 over x plus 1, and I multiply everything by the highest power x, but it's reciprocal. The highest power x is just x to the 1 power. So if I multiply the top by 1 over x and the bottom by 1 over x, whatever you do the top, you can do the bottom. So if I distribute this and I go 2x times 1 over x, minus 1 times 1 over x, then I get x times, hang on, x times 1 over x plus 1 times 1 over x. What I get here, the x's cancel and I get 2. Here, negative 1 times 1 over x is a negative 1 over x. And here the x's cancel and I get 1 plus 1 over x. If I set this, this is the same as this. It's just rearranged a little bit. If I make x approach infinity, do you see if I put infinity here, 1 divided by infinity, it turns to 0. 1 divided by infinity, this turns to 0. 2 minus 0 equals 2. And 1 plus 0 equals 1, so I get 2. So you can divide by whatever the highest power is, 1 over x, 1 over x. If they were x squares, then you could do 1 over x squared, 1 over x squared. And you can see that you'd end up, if the powers are the same, you're going to end up with the coefficients in front, just like those horizontal asymptotes. So everybody get that? I hope everybody sees that. If I plug infinity in here, I get 0. So my answer is 5 minus 0, which is 5. If I plug infinity in here, 2.7 to the infinite power becomes larger and larger and larger, turns to infinity. 3 divided by infinity, just like this right here, 2 divided by infinity becomes 0. Here, if I put infinity in these, you can go through and multiply it by 1 over x, or just see the powers are the same. So this limit becomes 2. All right, going to the next problem. It takes much longer to do this on this page, on the online. So when you do these problems, I mean, these numbers are actually insignificant when we're dealing with infinity. You know, just a whole number sometimes, if they're added, infinity plus 5 is still infinity. So those numbers become insignificant if you look at it. So this is 2x over 3x squared. We don't want, if I'm going to plug infinity in here and add 5, it doesn't make sense. Infinity plus 5 is still infinity. Now, so we're just looking at these numbers. Look, one of the x's can cancel, And this is what I have. Do you see how one of the x's can cancel? Now I can plug infinity in here. Now I can plug infinity in here. 2 over 3 times 2 over 3 times infinity. 3 times infinity is infinity, and 2 divided by infinity is 0. Do you see here how when the power on the bottom is larger, the horizontal asymptote was y equals 0. Here the limit is 0. When the powers are the same, it's the coefficient. We're just going to look at the x's. We have 2x squared and 3x square. You see these, once again, the 5 and the 1 are insignificant because we throw infinity in there and they mean nothing. These two cancel each other and we just have 2/3. Now, when the power on top is different, you can't say there's no limit. Well, you can, but there's infinite limits here. So let's just look at the numbers on top. 3x to the third over, or 2, I keep on saying 3. It's 2x to the third over 3x squared. If 2 of the x's cancel, I'm left with 2x over 3. And now if I plug infinity in there, 2 times infinity is still infinity. Infinity divided by 3 is still infinity. It's still a huge number. I can keep on going. Infinity just keeps on going. So this limit equals infinity there. And since we didn't get a number, just like the horizontal asymptote, there was no, here, if the power is smaller, the horizontal asymptote is y equals 0. Here, if the powers are the same, the horizontal asymptote is the coefficient. Here, if the power on the top is larger, there is no horizontal asymptote. If we get infinity, then we say the limit does not exist. If we actually get infinity, we got numbers for everything else. 2 divided by infinity is 0. Here we got 2/3. If we get infinity, then the limit does not exist. So we can plug infinity in there, and if we get infinity, then the limit does not exist. That's the way the book explains that. Very similar to the algebra horizontal asymptotes. Oh, no. Here's the sine wave. And let's just draw a graph real quick. I could have drew it better. That's the wrong sign. I mean, I'm sorry. That the sine wave really should have looked like this. If it's not letting me draw for some reason. Okay, so as x keeps on going, the graph goes up to 1, then it goes down to -1, goes up to 1. Do you see? As it goes into infinity, the graph still cycles back and forth. So there's no limit. It doesn't approach any number. Now, this next one, I don't want to do the next one. The next one shows, let me see how they're doing the next one. I don't know how they're showing this. I think the best way I could explain this yeah, I'm not even going to worry about this one. This one, I'm not even going to worry about. It's kind of hard to explain that. It's that one won't be on the test. By the way, the limit for that, if you want to look into the book on that one, the limit for this is 0. They show the squeeze rule. The limit for this is 0. If you put infinity in here, do you see? If you have any number divided by infinity, you're starting to approach 0. They use something called the squeeze rule. By the way, if you remember what this graph looks like, this graph looked like, if you knew the sine x graph, it actually looks like this. And it's getting smaller. If you look at this graph, it gets smaller and smaller and smaller. Closer and closer, it cycles back and forth, closer and closer to 0. So if you see the limit, eventually it's getting so small it stays right on the 0 line. So you can actually look at that graph and see that as you go farther on, if you change out your domain, your window to like 1 million or not, maybe not 1 million, maybe 1,000, you see that the graph gets smaller and smaller, and it actually approaches 0. So that's a good one you can actually do on your calculator. Let's put that on our calculator. I want to do that one on our calculator. So I'm going to hit y equals and put sine x, because you're going to be using your calculators for all these future tests. Sine x divided by x, and I'm going to change my window to -10, 10. And it's really hard to see, so I'm going to change my x values to -1, 1. That didn't work. Oh, x value should still be -10, 10. My y value should change. Yes. So let me show you that on my calculator. So on my calculator, I changed my window. Sorry, I'm trying to figure out how this thing is set up. I changed my window. The x value is -10 to 10, but my y's minimum and maximum are -1 and 1, because that's how high the sine graph grows. Do you see how it keeps on getting smaller and smaller? So if I change my x value to negative, or I don't even have to worry about the negative side. Let's just put -1 to 100. So if I'm going on the x value closer to infinity to 100, and you see how the graph gets smaller and smaller, and it's starting to approach 0. The y value starts, it starts up higher here, gets smaller and smaller and smaller, and it starts to approach 0. So the limit as it goes to infinity, it's approaching 0. And you can actually go on your table and you see those y values getting smaller and smaller and smaller. And they're all, even though they're going on negative and positive, they're getting smaller. And as I'm going down, they're approaching 0, getting closer and closer. The farther I get, the closer it gets to 0. All right, so we have some more limits. If I put infinity into here, infinity to the third, anybody know what infinity to the third equals? Infinity times infinity times infinity is just infinity. Same way with negative infinity to the third. The negative sign holds true, so it's negative infinity. We have a couple more limits to do. So I'm going to mathematically do these limits. I'm going to mathematically do these limits. And the way I mathematically do these limits, I multiply the top and bottom by the highest power, the reciprocal of the highest power, which is x squared. So I'm going to multiply the top and bottom by 1 over x squared. See, the x squared is the highest power. So when I distribute that, I end up with 2 times 2. I end up with 2. Uh-oh, it's not letting me write. Why isn't it letting me write? Oh, let me clear everything. It's not even letting me clear. Uh-oh. Why isn't it letting? Okay, let's try this again. If I multiply by 1 over x squared, 1 over x squared, I get 2, it's not, there it goes, 2x squared times 1 over x squared plus 5x times 1 over x squared all over x times 1 over x squared plus 1 times 1 over x squared. So I'm distributing x squared to each term. These cancel, and I'm left with 2. One of these cancel, and I'm left with 5 over x. Here, I'm left with 1 over x, and here, I'm left with 1 over x squared. Now, if I plug infinity into all of these, because we're plugging x to infinity into all of these, if I plug infinity in, 5 divided by infinity is 0, so I'm left with 2 plus 0. 1 divided by infinity is 0. 1 divided by infinity is 0. 0 plus 0 is 0. I get 2 over 0, which is undefined. Once again, if you notice, if you have a higher power, the higher power is larger than the bottom, then there's no horizontal asymptote, or we can say there is no limit. If the if the power on top is larger, we can say there's no limit. And the same thing goes, I think they want you to do the same thing. But we're dealing with, I keep on saying no limits. The same thing as no asymptotes. But in reality, if we look at this, there is a limit here. If we say, if we're not saying that there's no infinity limits, there are limits. So you could say no limit, but that's not going to be one of your choices for multiple choice. If there's no limit, you have to go back to the way we showed this. The highest powers on the top and bottom is this. We get 2x. One of the x's cancel. You put infinity in here. 2 times infinity is infinity. So you actually get a limit of infinity. So if you do it mathematically, you get undefined and you say, oh, that means there's no limit. But when you're dealing with infinite limits, there are always limits. So when you look at that, if the powers on top is higher, you cancel one of those out and your limit is actually going to positive infinity. Same way with here. You end up with one of the x's cancel and you put negative infinity in here, you end up with 2 times negative infinity is negative infinity. So when we're dealing with, when it tells you we're dealing with infinite limits, you can say infinity or negative infinity. If it doesn't say infinite limits, then you have to say there's no limit. And when we do the review, I'll show you that in problems that say infinite limits, you can say infinity. If the problem just says what is the limit, like this one, it says find the limits, the answer should be no limit, but find the limit for, it should say for the infinite limit problem. So on a test and in the homework, it usually says when you're dealing with infinite limits, find the limit. So then you can say infinity is your limit. Yeah, the book shows you, and by the way, this is example 8 on page 245. I'm going to just say, look at example 8 for section in the book, section 4.5, because it actually says find infinite limits at infinity. So it says find infinite limits. It does say that. I just didn't write it down here. That's why I put no limit at first. But if the problem says find infinite limits, then the answer would be infinity. Or the bottom answer, if you put negative 2 times infinite, negative infinity is negative infinity. So if it says infinite limits, infinity is a okay answer. It's the answer. And I think that was the last one. Yes, it was. Give me a second. This is so hard to maneuver. I usually use a different program, but they wanted everybody to use Zoom. I actually think Zoom's better if I just